The last type of last part of smoothing surfacing features that we can find in terrestrial planets is this process of erosion. Now we know it has to have some relationship to atmospheres, and the question is, hey, if a planet or moon has less atmosphere than Earth, does that mean it's going to have less erosion or more erosion? The argument for less erosion just means, hey, there's less material around to be grinding things apart. Whereas the argument for we'll have more erosion is that atmospheres act kind of like a lubricant, kind of softening, smoothing edges around. So if there's less atmosphere, there's less lubricant present, which can cause more erosion. Well, we'll just dive into this. This idea of lubricating is just wrong, right? If there's less atmosphere, there's less erosion. Atmosphere allows sand, dust. It gives it a way to transmit, and you have more material flying around, bouncing, hitting off each other. Well, there's more interactions. Greater amounts of erosion can occur. Now, what erosion does is it wears down things that are high and just brings material down into the lower regions, filling it up. Examples here, a dune field on Mars, you can see the soil being stretched out. So it's filling in, taking loose grains, and just filling in the regions and grinding away at higher regions. So on Earth, wind and water are the biggest contributors to the erosion. And the winds can change the surfaces, change the features. Loose dust will fly around. So as that dust moves, the surface features can change slightly. Now for a big question that we're always constantly asking ourselves, is there water present on other planets? And if so, where? This is an image taken by the Martian rover Opportunity. And you see these kind of bands playing out. Is this indicative of signs of water on Mars? Looking in more detail on Mars, we see examples of patterns like this. They appear to be mineral deposits, and the image here is on Mars, whereas this one's just a stream bed on Earth. And, well, obviously there's a lot of comparisons that we can try and make. So the speculation here is that these were made by ancient stream beds on Mars when there was flowing water on the surface. So we stitch together what we think is a history of Mars, going from now where we see the desolate wasteland that is now, but go back to 4 billion years ago, early in a young Martian life, and we think it would have had a ocean surface in like the northern regions here. And we put a cloud there to depict types of storms happening. But over the ages, Mars' atmosphere started to disappear, get thinner, and the water started to recess closer and closer to the poles. So what we know for certain now is that we've detected deposits of ice underneath the surface, especially in the polar regions of Mars. And we think that certain craters, as well as just underneath the soil of Mars, there probably is water present. Getting away from Mars, we can talk about Venus, where we have this image of, is this what Venus looked like about 2 billion years ago? Speculation, we're not entirely certain. We do know that there are trace amounts of water vapor in the atmosphere, about 20 parts per million in the atmosphere of Venus, which actually the water contributes to the greenhouse effects on the Venus surface, raising the temperature. Other reasons that have led us to speculate the presence of water there is what we call these color differences between high and low regions. And we expect that the low regions might be filled with potential water. Liquid, we're not certain. And this is all. We just don't have enough information to confirm one way or another. Coming to our nearest neighbor, we can talk about potential water on the moon. And this is an image taken from the cross impact data. As with everything that scientists, or specifically physicists, like to do, we're going to build something to smash it into another thing and see what flies out. Well, we did this in the 90s, and we saw this plumes here. And those plumes had a high presence of hydrogen and oxygen and showed potential signs of being icy water being evaporated by this collision. What we know for certain is that our spectroscopic analysis of features on the moon have shown the presence indicative of water, not confirming it. It could be water. There could be this related chemical OH that's also present there. We're not certain. We're still trying to figure out. We suspect there are traces amounts. We've even found trace amounts of water vapor in the very thin atmosphere of the moon. And a interesting legal question that scholars are trying to figure out right now is, hey, if there's water there, it's going to be where we're going to put our first moon base. We're going to go to the moon and try to put lunar bases there. And the question is, well, who has the legal authority to access and use that resource? We have treaties signed by most of the world governments agreeing that you can't claim extraterrestrial territory. You can't just claim, you can't plant a flag on the moon and say this is now part of our nation. But what about using the resources that are available there? What if there are heavy minerals or heavy materials that we need? And this is a open legal question that people are constantly debating. Even on Mercury, we think we found pockets of ice there. This is based on radar observations from the Arecibo Observatory in Puerto Rico. And each of the yellow dots, this is close to the northern pole of Mercury. Each of these craters potentially has ice, water ice, frozen in these craters. So looking at the northern pole of Mercury is one of high interest too, to try and see what kind of materials are there. So wrapping up section 8, what are the things we talked about? We said that the terrestrial planets are composed of these refractory materials, the stuff that are resilient to changes. They try and keep their state. We use radiometric dating to figure out the ages, specifically when that rock was last molten. And we talked about how we use S and P waves, the primary and secondary waves, to probe the interior of planets to figure out what's going on inside them. Part of how we know about our tectonic plates and what's happening on Earth is actually the flipping magnetic field of Earth. That constant flipping gives us this clock to have another tool to measure the shift of the plates. That leads to all sorts of erosion and shifting of the continents. And last, we talked about how there are signs of water on all of the terrestrial objects. Definitive confirmation, we haven't found any liquid water out there. We know there are trace amounts of vapor and ice on every terrestrial object out there. And now the hunt is for a big deposit of them, something that we can use. So that, we'll call it into a section 8, and we'll see you next time.